All right. Thank you for coming. Happy Tuesday. I've got some announcements for you. First off, there's a math colloquium. So computer science as a major lives in the math and computer science department. And so there's a math colloquium that's happening tomorrow, which is at 1:30 up in 202 in Galileo. And the topic is asymptotic dimension for something like what does it mean for the Euclidean plane to be two-dimensional? Like, what does that mean? Um, so it should be really interesting if you want to go. It's free. It's at 1:30, so I don't know what they're calling it now, like community time or flex time. Up in Galileo 202. 201 you may have been in, that's the big lecture hall. 202 is just right next door to that. So that's going on. Directly after this class at 5:30, there's a meeting of the tech club, which is designed for computer science majors, minors, or anyone interested, to just get together and talk about things. The plan for tonight, I believe, they're working on LeetCode problems. LeetCode is like a website where you can, it's for like interview practice. So if you want to get like an internship or something, LeetCode is where you can practice a lot of these kinds of problems. There's also going to be pizza. So if you have questions for me, I can't stay very long after class because I have to go pick up the pizza. But that's at 5:30 in Galileo 105, just on the first floor, if you want to come. Reminder for you, thank you for everybody who turned in lab 1 and homework 1. A few of you, I left comments. Just make sure that I'd like you to submit your homework project the same way you submit the labs, which is to just zip the entire project and make sure it's named like your name and then homework 1. That just makes it easier for me on grading so that I don't have to go through and like rename. If every project is named CS222 homework 1, then I have to go and rename like, oh, this is for this student, this is for that student. And it takes a lot of time. So I appreciate you following the naming convention. And thank you for everyone who did that. Much appreciated.
Did that include me?
I don't think so. I think you're good.
Oh.
I left a comment on your submission if it applied to you. So if there's no comment, then you're good. Okay, so the plan for today, we're going to review what we did last time, reviewing the house class. You can find what we did last time on Canvas. So where that lives is, let me view this as a student. I should put out a new announcement so it doesn't show my apologies every time. But in the important info module, there's lecture links. If we click on that page, here's all the links to the lecture. And here is where you can either, if you click on it, it can open like preview, or you can just download house.java to compare with what you have to what I have. So after class, I saved it and then uploaded it here, and there we go. So yeah, so this is standard for what I do after class. I'll save any of the files that I work on, and then I'll upload them so you all have access to that. And I'll typically post them usually between like 5 and 6. Today it's going to be a little bit later because I have to go pick up pizza. But I'll try to get that in before the end of the day, usually. So this is a resource that's always available to you. My plan is we're going to keep going through this slide deck. I know I've kind of skipped over some of the packet problems, so my plan for today is to allow some time for you to like actually think about this. Maybe collaborate with your neighbors that you're sitting around with, and talk about some of these problems. But we'll continue on, and depending on how far we get, maybe we'll start working on lab 2. Okay, let's open Eclipse. Eclipse workspace. Alrighty. Okay, so we're in or for me, I'm in my more Java package. And last time we talked about reference variables, where reference variables are something that's more complicated than just primitive variables. Remember, primitives are your integers, your doubles, your booleans, your single characters. Those are primitive variables in Java. Reference variables are anything else more complicated than that. And we can define reference variables ourselves. And we did this with a house. We decided we're going to create a type that is house. And so when we're creating these types, or these reference types, there's a few main categories of things. And so this is, let's see, where are we? So problem 8 on the packet, of what are the 3 main components of a Java class? So in our house, we've got these properties, things that we're keeping track of. The official Java name for that is field. So fields are typically the variables, the properties that our type is going to have. So F is for field. So those are properties. So then we also have behaviors of things that we want this type to be able to do. And the official Java word for that is methods. So M for method, F for field, M for method. And then the other component is just how do we set all this up? How do we actually build this type that we're talking about? How do we actually create a variable for that? And that involves constructors. So C for constructor. Okay, let me pull up the slideshow. Okay, so we talked about these are the primitives where these are stored directly by value. This is something I would ask you on an exam. What's the difference between a primitive and a reference variable? Which is problem 5 on the packet, where if you write something like primitives are handled by value, references are handled by pointers or references, memory locations. If you write that down on a test, full credit. So the idea is we have, instead of the box for the variable that stores this value directly, it points to somewhere else and says, here's where this data lives. Okay, so this is the answer to problem 5. Okay. We talked about that. So we talked about like the properties and behaviors that a house can have. And then we made that house class. So I want to take a second to work on problem 6 for a street. Maybe trying to think how I want to do this. Maybe like turn your chair and talk with a neighbor of what properties do you think a street could have? What behavior might a street need to have? I think we're on the other side. We're back on problem 6. Cool. If you've got that, then turn to your neighbor and share that. Okay, go.
I said addresses, things, I said stop signs, I said, maybe mailboxes. Yeah, I said, and then. Okay. Here,
Maybe like.
for a screen. Think about it.
I said,
What do you? Oh, the behavior, I said, under construction, like that could be.
You did understood it, you like.
Yeah.
Say like, you know, these numbers, stop signs, or like.
Public, recreational, maybe, okay.
Like, number, like, street light. Yeah.
For you.
Okay.
Hmm.
Crossing set.
Yeah, so
Oh,
once,
it's,
once you
false
finish
connect.
problem 6, you have a good idea of what properties and behaviors.
that makes sense.
Go ahead and try, maybe try and define the street class in the same file as house. It doesn't work,
Yeah,
really?
I would think so. I think that'd be in some class.
Correct. So if it doesn't, so if it doesn't work in the same file, then create a new file and implement it.
Talks about my lab one submission. to the
Yeah.
previous period.
Yeah, sure.
Oh, yeah, I should go.
Okay, so you've got your fields declared. So now maybe add some getters and setters. Remember how to do that?
I don't remember what the like short.
So, okay, so you right click in the code. And then go to stores. And then generate getters and setters.
Okay.
Where you going? Yeah, so I'm thinking maybe like for housing. Or maybe, because the street has a certain number of like addresses associated, like the 100 block of Main Street.
Okay.
So maybe have like an array.
Yeah.
of, like these are the houses,
Yeah, okay.
that's a possibility. Yeah. Oh, no, 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 no. Yeah. No. And then maybe you can kind of like, how many cars to maximum amount of cars I think it's almost really or like a highway has, I don't know, a highway has like a rating where like you've ever seen like the trucks above a certain weight limit can't go on this road. So maybe that's an important, I mean, that probably would go more than like property. Yeah. Anybody else have ideas? What sort of behaviors do you want a street to have?
Not full of cars.
Not full car?
You wouldn't want to street that would be full of cars, so you can drive through it and not that one.
Maybe the street has like an intersection. Stop it, like turn the light red. Turn the light green. So the property would be, is the light red, yellow, and green. The behavior would be make those red light, red, yellow, and green. So like, if you've got it, like, if the property is the door is either open or closed, the behavior, the action is open. Closed. Like for the house, we've got a number of floors. And one of the behaviors I have is like renovate, so add a floor to the house.
So, that said, the properties could have a sidewalk. That goes with the behaviors if there's something blocking. Without.
No, so is there somebody walking south of the property? Or yes or no?
Sense.
Yeah, yeah, like pedestrian walks. Let's see.
All I'm sure we have it.
All right, let's just briefly talk about like Maybe we'll make. So first of all, if I wanted to make so let's say I've got public class house and I have my curly bracket here and my closing curly bracket all the way at the bottom. So that defines my house class, the house type that I'm about to use. If I wanted to do public class street and define something in here, that's going to give me an error saying the public type street must be defined in its own file. So one class per one file. So the answer to problem 7 is false. So let's make a street class. And the name is street. I'm not,
Lab 2.
this is not lab 2 yet. So I'm not gonna include a main method. I'm just gonna name it street and click finish. So what sort of fields did you give it? I know back there we were talking about like a traffic light. I don't know how we would probably need to make another like traffic light class.
Are we supposed to make a street class?
Yeah, that's what we're doing right now. Not for anything in depth or that you turn in, but just for a thought experiment. Not at the moment, but it may be active learning. I haven't decided what you'll turn in for active learning yet. So maybe we have a traffic light. Any other properties you thought of? Pedestrians. So maybe that's Boolean pedestrians on sidewalk. So the way that I set up my fields are typically I'm declaring variables. Maybe we have a notion of are there houses on the street? So maybe we need a list or an array of houses. So we've defined what it means to be a house. It has all of these properties of itself. And so for a street, we can say, okay, there's a number of houses on my street. So here's a list of all of them. Any other ideas? Anything particularly cool that seemed to you?
Wasn't in particularly over the plugin question.
Mhm.
I know we did house. We put like in the constructor, we put string address, and like say what the string for address was. If we had two things that were strings, would we just put string address, comma string, and then whatever else it was?
Yeah. Yeah, that's absolutely possible. They're just named, so let's make like a public street, and make our constructor. Maybe the name of the street and I don't know, something else, some other thing that gets fed into a data point. And since they have two distinct variable names, you just refer to one and refer to the other. And their name is what distinguishes them. So you have to make sure that the user, either it's you or it's somebody else, knows that like the street name gets put first, the first argument, and then the thing after that gets put after that. Cool. Okay, so that's my street journey. So that's problem 9. Problem 10, we also kind of talked about this a little bit. Every type has to go in its own file, and the name of the class has to match the name of the file down to the uppercase letter. We talked about fields and methods. Typical fields and methods, trying to decide whether we're not. I don't know when you usually do this. I'll think about it. So we've got basic methods like, which we call setters and getters, which since we have these fields, these properties, the setters and getters basically get the state of the property, like it gets how many floors does this house have, and then that's the getter, and then setter is just saying this house has 10 floors. I'm saying that. So for some properties, it makes sense to be able to mutate those and access those directly. In other senses, like maybe the number of floors, it doesn't make sense to just magically say this house has 10 floors now. So it depends on the structure that you're creating. And so once we have our fields and our methods, we need our constructor. So for houses, we've got the blueprint, but we need to actually figure out how do we make it. And so the constructor says, I have all of these fields and I need to set up them in some way when I create this variable. And so for our house, we say if maybe we're just going to have a default studio apartment. And so that's what this means for these fields, where we say I'm assuming I get in the address, and I'm saying initially it's just a 1 floor, 1 bath, 0 bedrooms, and all the doors are currently closed and there's no animal. So I, as the designer, set up, this is how my house is going to look. And that's the constructor. And so when we want to test it out, this is a question, and when you're creating this class, do you need a main method or not? Do you check that box that says public static void main? In order to run something, to actually do anything, we do need a main method. The question is just, does it go in this file, in the house.java file, or should it go somewhere else? The answer is typically that we tend to prefer it goes somewhere else. And that somewhere else is called a driver file.
Wait, so what's the answer to question 10?
The answer to question 10, a driver class is a class with a main method. A driver class is a class with a main method. And typically it's not the same. We don't typically want the main method to go in the type, the class that we're defining. So the driver is a class with a main method. And then the answer to the question after that is outside it. Okay, and then where we left off last time is here, I'm going to copy this code that I wrote last time, and I'm gonna, because this is for February 20th, so I'm gonna make a February 25th driver class. And I'm gonna give it a main because I want it to be able to run something. So I'll check the main box. So so now I've defined the house class. I've defined the house type. So there's primitive and reference types. I've defined a reference type. and I've called it house. And so now I can create a variable of type house. And so the left-hand side of that equal sign looks just like before, where we have the type name and then the variable name, which here I've done house H. Could call it house, lowercase house, or house, yeah, or house number 1. Doesn't matter. It's a variable name. It can be whatever you want. That's declaring. And then we need to actually make the variable be something. And so now we have the right-hand side of the equation. And this process, so for a primitive variable, the right-hand side is called initializing, where we're setting this up to be some value. This is declaring and initializing. For reference, that this initializing applies to primitive variables. This is called instantiating, and that applies to reference variables. So the answer to problem 11 is instantiating, where this is where we've created a house and given it some initial values. Okay, so problem 12 is,
Wait, what is, it a problem 11?
the answer to problem 11 is instantiating. Okay, everybody good? All right, so problem 12 is, so this has a variable name of actual, like, word house 1. So I would like you to, here, let me delete that line. So I want you to declare or set up another house variable. So maybe make it as 124 Main Street or 9,999 Main Street or 1928 St. Mary's Road. Set up a new house variable, give it an address, and then try doing something like house 1, like print the result of house 1 equals house 2. Or print the result of house 1 plus house 2. There's all of these operations here, and I want to know what's the result of them. Some of them probably will error, so I would like to know, do they error or not? What does it give you? Yeah, question. Yeah. Yeah. And so the main constructor that I have is just the address.
Yeah. Okay.
But I'll go over to that. I set up, so when you go to the constructor, or the start. Oh, so yeah, so it just says this not address.
Yeah.
I set up other information on there as well. So. Yeah, I set up like only one floor. And all of this other information.
Yeah, are we supposed to put it for every single operation?
Yeah, or do it, so the idea. Can I go on, or are you copying? Okay. The idea is you have one print statement, and in that print statement, you keep editing to try the different operations. So you don't need like however many print statement lines, you just need one and just try out each of them. Yeah, you need to, so you need to make house 2 variable. So like capital H house 2.
Is that just the same as this one? Just
Yeah.
faster?
Yeah, so just change the variable name and then change the address. Or keep the address the same.
Well,
You good?
Oh, yes.
All right, I'm gonna move on to the other file. Okay, someone read aloud their code to me to tell me how to define house 2.
How to.
I need something at the beginning. What do I need?
House 2.
Yeah, so capital H house. I have, because in Java, we need to say, here's the type of this variable. And so capital H house, that's the type.
Why don't you have to do this for house 1 though?
So you can do it in separate lines. Yeah. So this is the declaring, this is the instantiating. You can either do it on separate lines or you can do it on the same line. Question?
Oh, you can also, so it would also work if we declared house 2 before.
Yes. Yeah. So either you have it on one line or put a semicolon and then say house or say the right variable name. Yeah. Either works. Okay, yeah, so let's talk about the operation. What about equals equals?
false.
False? So does that make sense? So 123 Main Street is not 124 Main Street? What if we have 123 Main Street for both of them? We think it should be true, right? It's false. Why?
Because it's not the same thing.
Yeah, so it's not, so remember, reference variables, when we use equals equals, reference variables are looking for, does it live in the same place in memory? And since house 1 and house 2 are separate variables and they don't live in the same place in memory, when we use equals equals, it says false. The way that we fix this, if we want it to be equals, we need to define a method called like public Boolean equals. I'm just gonna return false for now. We'll look at this method in more detail when we look at object oriented, But this is the way that we would get around that, where we can say, does this house, what does it mean for two houses to be equal to each other? In which case we would probably look at the fields, like, are they at the same address? Do they have the same number of floors, number of bathrooms and bedrooms and stuff like that? So checking all of the properties that we care about, are these all equal? In which case we would probably say that the two houses are equal. But we'll go over this in more detail on another day. But for now, just know that the equals is looking for memory location equality. So even if they have all the same fields, because they live different places, it's not equals. Let's try it's happening again. The house is losing all meaning. Let's try, we can set house 3 equal to house 1. And so now in theory, they're pointing, house 3 and house 1 are both pointing to the same place in memory. So now if we do, instead of house 2, we do house 3, we should get true. There. So now, since they're pointing to the same thing, now it's true. But when they're pointing to different places, even though the data points are the same, if they're pointing different places, it's false. Okay, so let's change this back to house 2. What about plus? Does plus work? No. Because what does it mean to add two houses together? I have no idea. We would need to define what that means. So plus the error even says the operator is undefined. So Java doesn't know what it means to add two houses together. I don't know what it means to add two houses together. So the operation is undefined. Okay. Not equals? Yeah, that works. So it's the opposite of the two equal signs. Do they live in the same? This is asking, do they not live at the same place? So we would expect this to be true. Because house 1 and house 2 don't live at the same place in memory. Minus? Undefined, for the same reason. What does it mean to subtract one house from another? I don't know. One equal sign? I mean, there's nothing really to print because one equal sign is just an assignment operator, which we see here works perfectly fine. We're reviewing problem 12.
Okay.
So the one equal sign works, it's the assignment operator. So the assignment in most programming languages works this is your right to left. So it assigns house 1 to house 3. Okay, that's one equal sign. Star. The arithmetic operations are going to be undefined. If you go to a language like C or maybe C++, these may work, the arithmetic operations, because they allow you to handle these references directly. But Java is like, no, I don't want you doing that. Okay, so that's going to be true for dividing and the modulus operator. Greater than and less than, also similarly, like, what does that mean? I have no idea. Yeah. Or if we did the one equal sign, let's test it. I'm guessing it's printing the what we call the hash code of house 1. So it's technically doing this, and it's like, okay, I don't know what to print, so I'm just gonna print the object that you gave me. Okay, that's problem 12. Any questions on that? Great. We talked about this where the setup for type is first we have the, where'd my mouse go? First we have the type name, which starts with capital letter for reference variables. The variable name, equal sign or semicolon, new, the type name again, and then parentheses, and then here's the arguments that we set up our constructor to have. And the right-hand side of this is called instantiating, which we talked about. We did this. Okay, so house 1 and house 2, these are both concrete things that we can work with in code. The word we use to describe those two things are objects. So house 1 and house 2 are objects. And the definition I might ask you to write down on an exam, what is an object? An object is an instance of a non-primitive type. So we've talked about, so an object is this actual thing that we have in code, this house 1. It's the difference between knowing what's my outline for the book versus having an actual, I don't have a book with me, but like having an actual book in my hands. And like there can be multiple copies of this book, but I have one of them. Or I've got my mug here. It's a difference between, oh, a red Yeti mug exists versus this is my mug. It's got like a label on it. This is a concrete instance. It's an instance of the general type of Yeti mugs. Yeah, so an object is an instance of a non-primitive type. So the non-primitive type for our house is house. And the instance, the house 1 is just an instance of house. Okay, so that's problem 13.
What is?
Problem 13, the answer is an object is an instance of a non-primitive type. Okay, I'm about to move on. Okay, so the methods in the slides are a little bit different because we did crowdsourcing for the methods in-house. But let's say that we want to actually do some of these methods. So for my house, I've got open front door. Let's say I actually want to open the front door. The way that I call that is I've got my variable name, house 1, and then I call my open front door method that belongs to a house. Every house has an open front door method. So I say dot, and then this little box shows up of, here's all the options that I could do. So I can start typing open front door. I can either type it all out, or I can see it's selected here and then just hit enter. So this is how I actually open the door of my house. And so that's the answer for 14, which is the second one, where we have the variable name dot the method name, parentheses. Right, so the variable name dot method name, and then whatever arguments there are. You'll see, sometimes I see, like I typed house 1 dot open front door. but it's not working. The reason it's case sensitive. So I've named the method open capital F front capital D door, so that has to be reflected. So this gives me an error, but this doesn't.
So the answer to that is house one dot open.
Correct. Okay. That's how we actually use a method. So the question is, what happens when we try to print our house one variable? Maybe I can spell house correctly, house one. What do we think? We've already kind of seen this. Do we think it should print the address? I mean, that probably makes sense, maybe, but we never defined what it means to print a house. And so there's a default way of printing an object, and Java set this up. We'll talk about this later again. And this is what it gives us. It just gives us what is called the hash code, which is sort of like,
The one with the at symbol.
yeah. So it's saying, here's where it lives. It lives in the U2 More Java package. The type name is house. And this is an approximation of the object. So the way that we get it to actually print something is, let's go to house. Is we need a method called toString whose return type is capital S string and whose name is literally lowercase 2 uppercase S string. And then maybe here we'll just return the address. There shouldn't be anything in the parameters, no parameters. For now, we'll just return the address. And we can define whatever this looks like. If we wanted to add additional information about our house, like this is the address and there are 3 animals living here, we could add that if we want. But for now, we'll just go with address. So I'll save that. Park here for a second in case you need to copy it down. Okay, I'm switching. And then if we print it again, now it prints the address. So the toString is what print calls. And that's a special method that types can implement. Okay, again, we'll have more later.
What problem are we on?
We're between 14 and 15. We'll get there in a second. So now I have to mention the garbage collector, which is a thing in Java where it manages like unreachable code, and it'll go through and it'll like delete those objects when it's not reachable. So once an object is unreachable, so like say we define it in a method and then we exit out of the method, if we didn't return it, then just consider it gone. So when we can't reach it, it's gone. Out of sight, out of mind. Garbage collection cleans up behind the scenes. If it's unreachable, then it's like, okay, you're done with this. Goodbye. If you need to do more in-depth work that may require you working with a garbage collector, I encourage you to read up more on this. My advisor in grad school also did like research on the garbage collector of how can we optimize it? How can we work with this? So it's also kind of an open question, which is interesting. Okay, so I need to talk about reallocation for the lab. So remember, arrays are this linear structure. We've got this series of boxes where we can index them starting at 0 and access it with the square brackets. We only have one type of variable in a list, and we can't change the size once we make it. So let's say we've got our box of candy and we want to add another piece. So like say we've got candy corn. We want to add the candy corn to our box. We can't change the size of the box once it's created. So once we've got our 10 pieces of candy, we can't like add on another box at the end. Java doesn't allow that. The solution for reallocation, which is the middle point on lab 2, the middle problem, is reallocation, which is the process of making a bigger box. So we can't change the original one, so make a bigger one and then copy everything over. So I've got a visualization. So this is, we've got our original box and our new candy that we want to add. So we make a bigger box. So for this one, I've just added one slot. Typically, if an array gets full, you create a new array with 2 times the space that you originally had, which I think is what I asked you to do in the lab. But for this one, we just add 1 additional space. So typically it's more than that. But we create a new array that's bigger. And then we copy everything over. So we set up a for loop and we say, okay, now the Rolos go here, the M&Ms go here, the Twizzlers go here, the Milky Way goes here, Skittles go here, and so on. So we set up a for loop to copy all those things over. And then at the very end, we say, here's my new data. Here it is. It's got a spot now. So the candy corn, once we've copied all those things over, then the candy corn goes in space 10. That's reallocation. And then once we're done with that, we've got, here's my new box of candy.
Wait, you know what?
This is information you'll need to do lab 2. We're not there quite yet. So the reallocation steps, again, first create a new array. So you declare and you allocate it with the new size. In terms of how big it should be, typically like 2 times the old size, but it can vary. Then you copy all the old things over, and then you add any new things you need to add there. And then you work only with the new array, and you throw away the old one. Any questions on that?
How do you like throw away the old?
You just ignore it. So for the lab 2, do I have it here? I do not have it open. Let me open lab 2. I'll go over it again once we get there. Okay, so I have a array reallocate where I give you here's the original array, and I give you here's how big I want the size to be now. And so instead of, and then you just return the new array. So like if you call it C2, return C2. And then in here you would like save result. You could like save result as result 2 or something, and then only work with that new version. Other questions?
Start working on that.
Not yet. Sorry. There's a lot of things that we need to talk about for you to be able to do lab 2.
This class.
Sure hope so. We'll see. So I have to talk about strings, and then I have to talk about lists, and then you should be good to go. So we've talked with strings. Strings are what we use with the double quotes. Some things to know about it. Strings are a reference type, so they are not primitive. Just a character, a single character with the single quotes is a primitive type. Strings with double quotes are reference types. We'll talk about all of these things in further slides. So reference type is something more complicated than a primitive. A character is a primitive, and so since we've got a sequence of characters, the strings are more complicated. So it's like an array where it's just one character after another. That's a string. Strings are immutable. So if you've ever played with like the clay where you can make something and then, or like Play-Doh where you can like smash it and make something new, you can't do that with strings. They're like the clay that you make and then bake, and then you can't like mold it anymore after that. Once you make it, you can't modify it. However, you can reassign that variable to be a new string or replace it as needed. So if you've got your like little clay monster here, and then you make a new clay monster that has like a unicorn horn or something, you can be like, okay, this old clay monster, nope, don't care about it. I only care about the new clay monster. So this is the problem 15 of have a string S1, declare it and make it equal to something. So remember we say, so strings are reference types. So I will say that there's an option to either set it up like equals and then the string hello. That's an option. Or you can set it up like we did with a house, where we can say new string and then give hello to the constructor. Different ways to get to the same place. So for 15, make a string S1 equals something, done that. And then make it equal to something else. So reassign it. So that's just asking S1 equals some string other than hello. And that works. We're allowed to do that. So let's say if we printed S1 after that, and then, so let's say we printed S1 after each step just to see what it is. If we set it up as hello, we expect to print hello first, and then we said now it's equal to something else. Then we expect it to print something else. What's the question?
What would we do after we make the hello string?
You say you reassign the variable S1 or whatever you called it. You reassign it to some other string. So you reassign it to something else. So if I run that, then at first S1 was hello, and now S1 is something else. So this is perfectly great. That's fine. We can do this. So that's 15 of just do that, try it out. Concatenation is an important operation that we can do with strings, where as part of replacing this string, we can add something to the replacement. So like if we start with ABCD, we can add to the replacement EF. So we can add onto it at the end and then say, okay, now S1 is not ABCD, now it's ABCDEF. The way we can do that is with plus equals. So let's do that. So let's say S2 is ABCD. I have to say what type it is. It's a string. And so we can say S2 was ABCD. Now I want to add EF to that. that's the equivalent of saying S2 equals, so doing that assignment operator. And I want it to be what S2 is currently and add EF to it. Bless you. So that's what this plus equals is shorthand for. So I want it to be equal to the thing it was before, plus a little bit more. And so now if I print S2, then I get A, B, C, D, E, F. So the plus equals is we've replaced the old A, B, C, D. It's now A, B, C, D, E, F.
B, C, D, E. H.
You can add however many letters you want here. So yeah, so that's what this middle bullet point is explaining. And the word we use to describe this is concatenate, which is what you've also seen me do in when I print things with the plus operator. That's concatenation with strings, which basically just smushes two strings together. That's what we're doing. In order to know how long a string is, so like for arrays, we used, oh gosh, I can never remember, length. And one dot, yeah, it is length. Yeah, so just dot length with no parentheses. That's how we do it for arrays. For strings, if we want to get the size of string 2, S2 dot, it's not size, it's dot length with parentheses. Length is a method that belongs to the string type. They've defined what that means. So we just call length, open, close parentheses. That gives us how big the string is. And so if let me print S2 dot length, and we would expect it, ABCD is 4, E, F, G, H, I. That would give us 9 letters. So I expect that number to be 9. And there we go. 9 letters. So dot length, string name, dot length, open parentheses, close parentheses. Length is a method that belongs to a string. In order to get individual characters, we can use a method called char at, so getting the character at a specified index. So in Python, you could do something like if you had S2 equals ABCD, you could say S2 bracket and use indices like it was a list or an array. In Java, it doesn't let us do that. So we have to say S2 dot char at and give it the index like that. Yeah, question. Yeah, that's the next thing. So char at, that's how we get the, now I want to say Pokemon. That's how we get the character at a specific index. So there's a way to get, let's see. The answer to your question is in a few slides. But let's say we want, if I have a string that says my name is Sarah, or my name is insert your name. If I just want the name from there, I can get that with either like having repeated char ats for however long your name is. But if your name is really super long, then that may be ill-advised. So another way to do it is substring. So that substring, that's equivalent to like slices in Python. If you remember doing like from 0 to index 3, if that looks familiar, this is equivalent to substring in Java, where you're starting at the first index and you're ending one before the second index that you're given. So so if you start typing substring, it'll show you there's a few options. So either I give it just the begin index, and so it takes this string and goes to the end, or I can give it a start and an end. So that's equivalent to like character 2 on with just like 2 colon in Python. That's equivalent to substring with just one argument. But if I give it 2 to 5 or 2 just until before 5, then that's equivalent to substring with 2 arguments. So actually let's say S3 is equal to, my name is Sarah. And then, oh gosh. 2, 3, 7, 8, 9, 10, 11. So either I can just give it one number 11, which I believe is where my name starts. And that goes from there to the end, which is what we want. The other way to get it is to give it S2 dot length, which is because strings also start counting at 0 for the indices. Okay, let's try it both ways. No. Was I wrong about substring? Extends the character at end index -1. No, so that was correct. Oh. Using the wrong variable.
We have problem 17.
Yeah, this is problem 17. Okay, but why? Yeah, no. Maybe I should have the same variable name for all of it. I think that would be a great idea. Okay, now I got the substring, but I didn't do anything with it. So let's system dot out print S3 dot substring. I'll go from 11 to S3's length. And now that gives me just Sarah. So this is practice using the substring method. So we have some string that we want to find the substring, and we need to give it 2 indices. Where do we start? Where do we stop? So for me, I know that my name starts at character 11, and it's going to go until the end of the string. So I give it 11 and then S3 dot length. So that's problem 17. Of if you do this, then you're good. That's just practice. You can write a check mark there. Okay. Are we good? All right.
Right.
Do you have a question?
I don't understand. I didn't quite get the substring.
Do you remember doing slices in Python? something that looks like, if S3 is our variable, where you can use square brackets of like character 2 to 5. We can talk about it more later too. Okay, so we have to talk about comparison, which is when we were with house, where we tried to do like less than and greater than. Sometimes we do actually need to compare things. So like, what does it mean for a string to be less than another? What do you think it could mean? Yeah,
I feel like, right?
could be length. Yeah, that's an option. Any other ideas? I'm thinking of like a dictionary where like if I have aardvark, boat, cat, and I order them, then I could say like aardvark comes before boat, comes before cat. Dictionary ordering, length ordering is also an option. Oh, I almost got all of them. Camera instead of cat. So again, there's this thing with equals where that's problem 18 of trying with equals. We did this with house, so I'll skip over this. But I will say, so let's say I've got S3 and then I want S4 to be the same exact thing. If we print S3 equals S4, since they're reference variables, we would get false. No, this happens to me every time. I get one of them right and one of them wrong. The reason, okay, this works as expected. It gives us actual true if they are the same string. That's because Java decided, okay, I'm gonna go easy on you and be like, if two strings contents are equal, then it's gonna be true. But don't expect this to work for a lot of other things. Should always verify whether or not it works. So they went easy on us this time. But if I were to use equals, I would say S3, the way I say the same thing is S3 dot equals parentheses, and in parentheses goes S4. Okay, so that's S3 dot equals S4. So that's how we do equals. I don't think I'm gonna demonstrate this, but I just want you to know that compare to is a way to compare one string to another. And the compare to is going to give you a number. Compare to gives you 0 if they're equal, if something equals something else. It's going to give you a number less than 0 if something comes before something else, and greater than 0 for something comes after something else. So these are functions that are defined, and string has defined what it means to compare one with another. And that meaning is the dictionary ordering. If you do this, if you try it out, problem 19 is comparing capital A aardvark to lowercase a aardvark. The answer is that they're going to be different. And the reason for that answer, so I would like you to like go home and try this.
Go home and try what?
Problem 19. The answer for that is in something called the Unicode. I always try this and I don't like any of the options. So this kind of works. Let's see if there's a better one. Okay, I do like this one. Okay, so each character is assigned a Unicode value. The way that the Unicode table is written is that the capital letters come before the lowercase letters. So we've got like our numbers 0 through 9, and then we've got punctuation, and then we've got capital letters. Then we've got some more punctuation. Then we've got lowercase letters. So capital A aardvark is going to give you a lower number than lowercase a aardvark, simply because capital A comes before lowercase a in the Unicode table. So that's the reason why. For parsing, so parsing is when we are splitting some input into parts. You'll see this in lab 3 as well, where I give you, here's a big long string. I need you to parse it, cut it up, and assign things to different places. So an example is, let's say you have a number 3.14, it's a string, but it's a number. So you want to work with it as a double. You can do that by using capital D double dot parse double and then giving it that string. And then saving it to a double variable. Let's see it. So
I tried talking 92, it says it becomes 32 units of water.
and so if A starts at 61 and then 61 minus 41,
What
I guess
value,
it's
what
20.
value is uppercase A?
You didn't use uppercase A?
No, like what value is it?
41.
S.
Okay, so let's say we've got a string that's 3.14. It's a string, it's not a number. If we try and add things, we'll just concatenate. So to actually get it as a double, I've got my double pi variable that's all set up and ready to receive this number. And I say capital D double dot parse capital D double. And I give it that string. I give it that string variable. That goes in the argument. The reason this has to be capital D is that the lowercase d double is a primitive type, and so it doesn't know how to do anything with strings. It's just a simple double. And so Java has defined these like reference versions of primitive types that lets us do more complicated things. And then once we're done with this, once we've done this parse double method, we can just save it to a simple double, and that's great. This also works with like capital I integer, capital B Boolean. There's similar things that we can do for the other primitive types. So you may remember this kind of for each loops. It's sometimes called an enhanced for loop. I don't know if we actually talk about the name when we talk about Python, but it's the difference between for I in range and for candy in bag, right? So it's a different way of working with the item, where a for each loop is working, we say for candy in bag. So we're working with for each candy in the bag. And so the candy variable is going to be each candy object. So it's a for each loop. We're going through and we're picking up each thing and working with that as a variable. And we can do this in Java too, where we have the word for, and we still have the parentheses, but inside the parentheses, it looks a little different, where we've got a colon that separates two halves. On the right-hand side is the name of the collection, so like the name of the array. And then on the left-hand side, we say, here's the type, and here's the variable name of just what I'm going to call it. And then inside the for loop, we do things. So let's look at 1, 2, 3. And so if I've got my array 1, 2, 3. So for integer int num, and then colon in my array A1, here's what I want to do. So maybe we just print number is, and then num. Num is now a variable that is used to associate with each thing in the array, one at a time. So once we run that, then we get number is 1, number is 2, and number is 3. This is a for each loop.
Alright. If you get to complete from 20.
Yeah, so this is problem 20. This is the problem 20, where here's my array, and I have a for each loop that sets it up and goes through each of the things. And I just print, here's that value. That's a for each loop. To answer your question, if we want to go maybe character by character through a string. So let's say we're working with S4, my name is Sarah. So for each, you need the type. So for integer, it's just int. And then you need square brackets, open and close. And then the variable name equals, and then for me, I just put curly brackets to define here are the initial values. Otherwise, you would say new int brackets, and in the brackets, that's how big you want it to be. Okay, so to split my name is Sarah to characters, you have what's the type of the thing that you're going to be iterating through? It's characters. I'm going to give each character, I'm going to call it C. And what's the thing I'm going to be going through? Let's say S4. But the way I split it into like an iterable thing is toChar array. And that's a method. So it's s4.toChar array, open and close parentheses. Maybe we'll print C. So if we do that,
I don't.
I'll come and help you afterwards. So if we do that, then we print my space name space is space Sarah. So it prints each individual character. The way we get that is toChar array. So that's how we go through all the characters. If we wanted to instead go through each word at a time, we can use a method called split. And so split takes a string of, here's where we're going to split at. I think Python also uses this. It's like, so for us, instead of, if we didn't want to do it to character array, we wanted to go through maybe string word. So for each word, actually, sorry, I'm gonna make a new for loop. For each word in S4 dot split. And I'm gonna give it space, so just split it by a space. And then let's just print that word. And so now it prints each word on its own line. So before we split it into individual characters, now we've split it into individual words. Okay. We don't have time for this. Okay. I promise we're getting to lab 2 at some point. At some point is next class. So next class is for active learning today. If you would please submit your driver file for today. So I've named it February 25th, whatever you've named it. That's active learning for today. Next time we will talk about lists and then I'll assign lab 2 groups and we'll work on lab 2. Sounds good?
Right.
Any questions?
I need help.
Okay, I'll come around to you. Do you have a question?
Yeah, it's a lot.
Okay. Any other general questions? Yeah. Is there a reason that it's a different eye?
Go back. Impact my, is that just because?
I'm confused as to wait.
Actually,
Oh, okay, cool. Any other questions?
Am I supposed to zip?
No, you
Okay.
don't have to, for active learning, just submit the .java. Just submit the .java. Okay, thank you. Submit this file for active learning. And I will see you on Thursday where we will actually finally really do lab 2.
I don't believe.
I believe me.